Snakes. For snakes, their body temperatures differ along the length of the animal. This is quite often a large difference in temperature. For example, Gregory found that garter snakes can have heads that are up to 13 degrees warmer than the rest of their body. This presumably means that there is such a difference in temperature due to controlled blood flow to two different regions of the animal's body. By controlling the blood flow in the snake's body, this is relating to the circulatory system, as it is regulating the temperature through the blood and therefore the heart rate. Snakes tend to keep their heads warmer and their tails cooler. The snake's tail could be up to 7 degrees cooler than its head. This distribution of heat is the result of localized vasoconstriction, which results in the decreased blood flow to the tail. Snakes are ectotherms. This means that a snake regulates its body temperature via taking heat or giving off heat to the environment. Because their body temperature is affected by environmental temperatures, it varies with surrounding conditions. Snakes become inactive during very hot weather and very cold seasons. Snakes may go several weeks without eating because of frequent periods of inactivity. This may be due to the hot or cold weather. In response to varying body temperatures, processes such as enzyme production can be modified. This is to acclimate the changes in temperature. Unlike snakes and ectothermic species, endotherms regulate their own internal body temperatures regardless of fluctuating external temperatures, while ectotherms rely on the external environment to regulate their internal body temperatures. Heat can be exchanged between environments and animal via radiation, evaporation, convection, or conduction.
Dogs only have endocrine sweat glands in their foot pads, so sweating is not a significant enough method for thermoregulation. Any heat loss caused by evaporation from the body is also minimized due to the dense hair that hinders the movement of liquid and vapor. So just getting a dog wet is not an effective enough tool, and this can cause the animal heat stress. In order to get cool by getting the dog wet, the water needs to be lower than the body temperature. The whole body needs to be submerged. However, if the temperature of the water is too low, it can cause shock or cardiac arrest. In this case, tap water is the best temperature. If the dog gets sprayed with water, it will stay within the dog's coat and the water will heat up to the dog's temperature. It will not evaporate, so the dog will stay hotter for a longer period of time. The water acts as a blanket and this will dry over time. For the thicker head, it will take longer to dry. When trying to cool a dog, putting them under a fan or outside in a breeze, the dog will dry faster using convection. Dogs normally use evaporation to cool themselves by using their nose or mouth, like panting, which uses evaporation directly from the respiratory tract. The success of panting is significantly changed depending on the humidity in the air. Drier climates improve the cooling effect, while high humidity decreases it. Conduction is used by transferring heat from one object to another. Some dogs may lie belly down on a cold floor to transfer heat. The heat transfers more effectively as the hair on the belly is thin. If a puddle is big enough for them to lie in and the water is cold, the cold water will move the heat away from the dog. Conduction through the dog's hair also occurs, but is not as efficient as directly through the skin. Dogs will also decrease their activity at the hottest times of the day, reducing their metabolism. Thermoregulation. There are 4 methods of heat transfer: convection, conduction, radiation, and evaporation. Convection is the movement of heat within a fluid. Conduction is the transfer of heat energy between atoms. Radiation occurs via electromagnetic waves, and evaporation transfers heat energy by evaporating particles from the surface of a liquid. The horse's organs and structures are changed when they are stressed. The organs and structures involved are the heart, lungs, digestive system, muscles, bronchial, blood vessels, nervous system and endocrine system. When a horse becomes stressed, the heart rate increases, meaning more blood is pumped around the body. The more blood pumping through the horse's lungs mean that the alveoli need to move more oxygen into the blood and take the carbon dioxide. The respiratory rate will increase as more oxygen is needed. The body's muscles use oxygen and glycogen to create movement. The body needs more blood going to the brain, heart and muscles, so the sympathetic nervous system decreases the blood to the intestinal and glandular activity. Because of this, you are not meant to work the horse an hour before or an hour after being fed, as the food would not get broken down correctly and it would cause colic. The brain is also put into flight response. The parasympathetic nervous system is part of an involuntary nervous system that serves to slow down the heart rate, increase intestinal and glandular activity, and relax the sphincter muscles. The sympathetic nervous system is part of the nervous system that serves to accelerate the heart rate, constrict blood vessels, and raise the blood pressure.
Sadly, for the purposes of this video, my horses are bomb-proof, so it is difficult to get a frightened response. While at rest in the stable, Flint's heart rate was at 37 beats per minute. Following that, it raised to 70 when entering his working area. When spooked, the heart rate rose to 132 beats per minute, and when under stress, which was jumping, it rose up to 118 beats per minute. This shows that a fright will cause a sudden spike in the horse's heart rate. Also, when put under stress, the heart rate will rise too. Some of the structures involved are nervous system and the endocrine system. The nervous system would have been told there is something scary from the sensory neurons that have got the information from the sensory receptors. The interneurons transfer the impulses and then the motor neurons head to work. The endocrine system uses hormones to help the response. The adrenal gland produces adrenaline. This also makes the heart and muscles work harder, but they don't feel fatigued.